All right, welcome to Graphing Sums and Products. So the learning goal, it's actually quite interesting. We're going to add, subtract, and multiply ordinates, okay? Now, what are ordinates? Ordinates are just y values, okay? Y values. So, for example, if I go y equals x squared, all right, if I go at x equals 3, the ordinate is y equals 9. So that's our ordinate. The y value at that point is 9. Okay. So we're going to do something interesting that we probably haven't done before, and we're going to add two different functions. We're going to subtract. We're going to multiply. Okay. Now, I'm just using my trig diagrams to do that. Now, what I have put is I've put the x values in radians, okay? Because that's what Desmos does, and it's also where we're heading as well. But underneath there, I've put the degree value of it, okay? So just be aware of that. Now, what is f of x? Well, f of x is sine x, g of x is cos of x, and then s of x is the addition of both those functions, okay? So in your calculator, if you go sine of 0 degrees, you should get the values here, which is 0. And if you go sine 45 degrees, you should get the value that we're going to get here, which is 1 on root 2. And that the exact value we get from these triangles that we've done, what is sine of 45 degrees. So hopefully you're starting to get used to that. And then you go sine of, and this is just f of x that I'm doing at the moment because I'm filling out that column in. If I go sine of 90 degrees, I get 1, okay? Sine of pi, I get 0. Sine of 270, I get -1, and then 2 pi is 0. Now, also, if you look here, the red one, which is f of x, okay, so this one here, is sine, okay, and you can clearly see that if I mark out the, let me use a different color, in degrees, so that's 0 degrees, over here, that's 45 degrees, this is 90 degrees, and then let's skip over here, that is 180 degrees, and over here is 270, and then finally here is 360 degrees. Alright, so you're aware of it. Now if you look at the graph, so we're just looking at the sine one, you can clearly see that at 0, the sine wave, the red one, is 0, the y value. At pi on 4, if you put it in your calculator, you'll get something close to that. So it should be like, just put in your calculator and you'll figure it out. And you can see that at 90 degrees, so at 90 degrees, your value is 1, okay? And then if we go 180, the sine value is 0. At 360, it's 0. And at 270, it's actually -1. So whether you use the graph or whether you use the calculator, you get the same thing. Now, for the sake of this video not going too long, I'm going to do quickly the cos value. So cos at the beginning is always 1. So remember, g of x is actually cos, okay? And then pi on 4 is actually the same value as sine, so 1 on root 2. And then it does sort of like the opposite thing. So at 90, and if we look at our graph, I'm going to choose, yeah, it's this blue one. So at 90 degrees, which is here, it actually becomes 0. And this is our cos graph here. So I'll put a purple highlighter over that so you can see that. So whether you use your calculator or the graph, you're going to get the same result because they're the same thing. So at 90, it's 0. At pi, it's actually -1. At 270, it's back to 0. And at 360, it's actually back to 1. And you can see that here, right here, that is 1. All right, now when we're adding ordinates, we're just adding y values. And all I've done is I've got a hell of a lot of y values here, okay? So because this is s of x is sine x plus cos x, all I have to do is add those values up. So I'm going to add them up. 0 plus 1 is 1. 1 on root 2 plus 1 on root 2 is root 2. 1 plus 0 is 1. 0 plus negative 1 is actually minus 1. Minus 1 plus 0 is minus 1 there. And then that will be back to 1. All right? And that's it. That's all we have to do. Now, what I want you to do is that we're going to focus just for a second on s of x. And I'll do a different color, so I'll put that color over it. Let's do s of x. I think I took away this one, that's 1. So let's do this, rub that off, and I'll use this highlighter for it. So that is the one in green. So it goes up here, down there, there. So that's the graphical representation of that. But now let's see if the table of values actually produces what we're talking about. At 0, it says the value is 1. Let's look at it. It actually is, okay? At pi on 4, 45 degrees, it's root 2. Now, if you go root 2, it's like 1.4, something like that. So I'm just going to double check it. Yeah, it's about 1.41. And if you look at it, that's the 1 value, and it actually is not quite 1.5. So there we go. Okay. At 90 degrees, it's actually 1, and yes, it's 1 again. All right. At pi, it's minus 1. So that's pi down there, and it actually is minus 1. At 270, or 3 pi on 2, it's actually minus 1. So let's look at it, and it is. It's right there. And at 2 pi, it's 1, and it actually is there. So all we have to do for this exercise is that we have to do a table of values that has 1, 2, 3 there. And we can put our points in, and we can draw an accurate graph. Now, the reason why I've got all these information in the graph here is that I want you to see that graphically you can do the same thing, okay? So if I'm going to grab I'm just going to rub all these out, okay? It's struggling to rub it out. There we go, okay? I can clearly see from the graph what I need to do. So I'm adding the red and blue ones because that's sine and cos. What's 0? I can clearly see plus 1. Well, it's just going to be 1, isn't it? And then this, see how they're both that length? So if I draw a line there, okay, and it means I have to double that. So I'm gonna copy, and then I'm going to paste it. It should be exactly the same distance to the top, and it actually is, all right? And if I go back to 90 degrees, which is here, it's going to be the blue plus red. Well, the blue is 0, the red is 1, so the green has to be 1, okay? At 180 degrees, the blue is negative 1, and the red is 0, so 0 plus negative 1 will win out there. So just like it is here, okay? Notice that from the graph, we get exactly the same thing, okay? So I'm going to do this one last time, and you get that there. So that looks like they're both that same length. So if I copy this and then paste it, I should get, if I can grab it, I don't know if I can grab it anymore. Oh, there we go. I should get right to that point down there, and I actually do. So we can either do a table of values. Table of values is way easier, but you can also see from the graph that to add the ordinates really, really works. Okay, so here we have, it's the same deal, except we're going to minus it, all right? Now, I'm very conscious of making the video too long. Okay, so I'm just going to fill out the gaps. So it's going to be the same numbers as before for this and this, all right? So sine always starts at 0. It ends at 0. In the middle, it actually is, because we're looking at the red one, it's actually 0. So in the middle of the graph, it's 0. And then at 270, it's minus 1. That's here. And at 90, it's 1, which is here. And then here will be the same, 1 on root 2. And cos is 1 on root 2 here as well. Now cos is different. It starts at 1, finishes at 1. In the middle, it's at minus 1, which is there. All right. And then at 270, it's actually 0. And at 90, it's 0. So let's look at that. That's there, and then that's there. Now if we're going to take these away, all I have to go is sine minus cos. So 0 minus 1 is just minus 1. And you can see here that we get that correct answer. Okay, and then we go 1 root 2 minus 1 root 2. So that's just, we're minusing the same amount, so that's got to be 0. And you can see here it's 0. 1 minus 0 is just 1, and we get 1. 0 minus 1, so that means we're going to get 1. So let's look at pi. There we go, and we are actually at 1. So really good for that. And then we go minus 1 minus 0 is just going to be minus 1, so 270, and it actually is. And then 0 minus 1 is actually minus 1 again, and that's the point here, and we actually do get minus 1 there. So you can see, doing a table of values or looking at the graph, we get the same thing. Now, this is not exclusive to trig graphs. It actually works with all your different functions. Okay, one last thing, okay? Here, and I'm going to write my values in 0, 1 on root 2, 1, 0, 0, negative 1, and this is 1, 1, and in the middle will be negative 1, and then that's 0, and that's 0, and that's the same as that. In this case, I've got it written the way I'm supposed to here and here, and the dot means times. Okay, so now we're not adding ordinates, we're multiplying ordinates. So I'm going to quickly do it in my table of values and see how we go. 0 times 1 is 0. Let's do all the zeros. That's going to be 0. That's going to be 0. That's going to be 0. And that's going to be 0. Now, this one's the only one in play. So 1 root 2. So I'm just going to do my scribble over here so you can see it. It's just going to be a half. So the answer of this is going to be a half. So I'm going to look at this one for the moment. So remember that this is 90 degrees, and so the middle of that, so right here is 45 degrees, okay? So that means that this value here, according to what we've written here, is a half. And look at this. Is it about halfway through from 0 to 1? You can clearly see that it's on the right track. Now let's look at all these zeros. So that's 180. That's 270, and that's 360 degrees, and you can see that all these zeros are all in play. This 0 is here, this 0 is here, this 0 is here. We're looking at the green graph. This 0 is here, and this 0 is here. Alright, so if I were to summarize what we're doing, is that we're doing a table of values old school style, alright, and then we're adding one extra row in and right here, and then whatever the question asks us to do, plus, minus, times, we do that with the value of the ordinates here. All right. Hopefully it makes sense. We'll definitely be working this in class. Peace.